In previous units, we looked at the effects of transformations on things like the shape, the center, and the spread of a distribution of data. So we examined what happened if you added or subtracted or multiplied or divided all of the possible outcomes in a distribution, what that would do to things like the shape of the distribution, the center of the distribution, the spread of the distribution. And what we discovered was that adding the same positive number, A, or subtracting that same number, A, from each observation would affect our measures of center and location. So our measures of center and location, our mean, our median, our quartiles, our percentiles, would all shift by that value. They would all have that value that we added or subtracted to each of them. So our mean would be altered by adding that value to the mean or subtracting the value from the mean. Our median would be the same. We would either add or subtract that value from the median, and so on. What we also learned, though, is it doesn't change the shape or the measure of spread, or measures of spread. So it doesn't affect the shape of the overall distribution. It also doesn't affect measures of spread, things like range, IQR, standard deviation. Because what we're doing when we're adding or subtracting a number from a distribution, it's almost like we're taking the entire distribution and picking it up and shifting it to the left or to the right by however many units we've added or subtracted. We also discovered that if we multiplied or divide each observation by the same positive number, then it's going to multiply or divide the measure of center and location. So the mean, the median, the quartiles, the percentiles, again, would all be multiplied by that value B. It also affects the spread. When we multiply or divide by a number, the measures of spread, the range, the IQR, the standard deviation, will also be multiplied by that value. But again, we also noticed previously that it doesn't affect the shape of those distributions. So what we're going to do is we're going to take these rules for transforming data, and we're going to see how they fit in when we're talking about the distribution of a random variable. In our first example, it says that Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. The number of passengers X on a randomly selected day has the following probability distribution. And so this table of values gives us the probability for each number. They said that we could have anywhere from 2 to 6 passengers. The probability of getting 2 passengers is 0.15. The probability of getting 3 is 0.25. The probability of 4 passengers is 0.35. Probability of 5 passengers is 0.20, and the probability of 6 passengers is 0.05. And notice that all of those probabilities add up to 1 because it has to be one of those possible outcomes. So what we're going to do is we're going to use the formula to compute the mean of the random variable X. We're going to interpret this value in context. So we said before that we can calculate the mean of a random variable, the mean of X. And again, in this case, X is the number of tourists on any randomly selected day, by taking the sum of the products of each value and their probability. In other words, our first possible outcome is 2. We're going to multiply that by the probability of having 2, which would be 0.15. Then we're going to add to that our next possible outcome, 3, times its likeliness, 0.25. Then we're going to add 4 times its likeliness, 0.35. Then we're going to add 5 times its likeliness, 0.20. And finally, we'll add 6 times its likeliness, 0.05. So to find the mean, we multiply and add each of those things together. If we do so, we find that the mean for X is 3.75. Now they also want us to interpret what that means in context to the problem. This is our average on any on any given day. In other words, we're just saying that Pete should expect an average of 3.75 passengers per trip that he makes. The next part wants us to use the formula to compute and interpret the standard deviation of the random variable x. And we said that to calculate the standard deviation, first we would need to calculate the variance of x. To do that, we're going to multiply each of the squared deviations times their probability. So for example, the deviation for our first value, 2, would be 2 minus the mean, 3.75 squared. That's our squared deviation. And then we multiply it times its probability, 0.15. Then we're going to add to that. Our next outcome is 3, so its deviation would be 3 minus 3.75. We're going to square that deviation and multiply it times its probability, 0.25. Then our next outcome is 4. So the deviation would be 4 minus the mean, 3.75. We square that and multiply it times the probability of 4 passengers, 0.35. Our next outcome is 5, so its deviation will be 5 minus 3.75, the mean, squared times the probability of 5 passengers, 0.20. And finally, our last possible outcome, 6 minus 3.75, gives us the deviation. We square that and multiply it times the probability of 6 passengers, which is 0.5. So now if we work all of that out, we get that the variance for x is equal to 1.1875. So then to find just the standard deviation of x, we would have to take the square root of our variance, the square root of 1.1875, which would be about 1.0897. So what does that mean in context to the situation? Well, remember that the standard deviation is how far above or below we would typically fall from the mean. So in other words, what we're saying is that on a randomly selected day, the number of people on a trip will typically vary from the mean by about 1.0897 passengers. So we're saying that the mean, on average, we would expect about 3.75, but anything above or below that by 1.0897 passengers, by about 1 passenger, would also be pretty typical, would not be too unusual. Remember that we can also calculate mean and standard deviation using our calculator. So let's take a look at what that would look like. In order to calculate the mean and the standard deviation for a discrete random variable, we're going to have to create lists. In one list, we need each value of the outcome, and in the other list, we need the probability that corresponds to those outcomes. So our possible outcomes are 2, 3, 4, 5, and 6. The corresponding probability for 2 is 0.15, for 3 is 0.25, for 4 is 0.35, for 5 is 0.2, and for 6 is 0.05. So then to calculate the mean, we'll exit out of that. We'll go to Stat. We'll choose the Calculate option, and we're running one variable stat, so choose option 1. Our list containing our values needs to go in as list, and list 1 is what contains our outcomes. Our frequency list, we're going to put the corresponding probability of each of those outcomes, and that was stored for me in list 2. Now if we go to calculate, we see that we do get a mean of 3.75, just as we calculated by hand. And we get a standard deviation of 1.0897, which is also what we calculated by hand. So in the next example, they tell us that Pete charges $150 per passenger. We're going to create a new random variable, C, that equals the total amount of money that Pete collects on a randomly selected trip. So let's see if we can write out that probability distribution of C. We need our total collected, and we want the probability of each of those totals. Now let's think about what it is that C is doing. Our random variable C is going to be the total amount of money that Pete collects. And so to find the total amount of money that Pete collects, we would have to take $150 for each passenger and multiply that by the number of passengers that he has on those trips. So C is equal to 150 times the number of passengers that he has on his trips. And we've already defined the number of passengers on his trip as a different random variable, X. So if we take X and we multiply it by 150, we'll get the amount that he's collected and the probability for each of those. So for example, the minimum number of passengers he could have would be 2 passengers. If he has 2 passengers, then he's going to have $150 times 2 passengers. The total collected would be $300. If he has 3 passengers, then 3 times 150 means he collects a total of $450. If he has 4 passengers, he would charge 4 times $150 each, so he would collect $600. If he has 5 passengers, he'd have 5 times $150, would mean that he collected a total of $750. And if he has 6 passengers, he would collect a total of $900, 6 times 150 each. We can stop there because it has to be between 2 and 6 passengers. You can't do more than 6 passengers. Now, what is the probability of each of those? Well, in order to collect $300, he had to have 2 passengers. And we've already established that the probability of having 2 passengers is 0.15. So there's a 0.15% chance that he is going to get $300, or 0.15 or 15% chance. The probability of having 3 passengers and collecting $450 is 0.25. The probability of having 4 passengers and collecting $600 is 0.35 or 35%. The probability of 5 passengers that would make him collect $750, 0.20. And the probability that he collects $900 having 6 passengers would be 0.05. So now what I'd like for you to do is I'd like for you to use your calculator to find the mean of the random variable and the standard deviation of the random variable. And make sure you interpret both of those into context. So using the steps that we just looked at on the previous example with our calculator, you don't have to do it by hand, see if you can calculate the mean and the standard deviation of C.